Good afternoon, sir. Good afternoon, classmate. We are the Group 4 and our topic for today is quality management. What are the objectives? Number 1, define the term quality and explain why quality is important and the consequences of poor quality. Number 2, identify the determinants of quality. Number 3, describe the costs associated with quality. Number 4, describe the quality awards and the philosophies of quality gurus. Number 5, describe TQM. Number 6, list and briefly explain the elements of the control process. And lastly, number 7, explain how control charts are used to monitor a process and the concepts that underlie their use. What is quality? Quality refers to the ability of a product or service to consistently meet or exceed customer requirements or expectations. So, ang quality ang mura ng kanamian kang product or service para ma-meet or masubrahan pa ang requirements kag expectation ka mga customers. Different customers will have different requirements, so a working definition of quality is customer dependent. For a decade or so, quality was an important focal point in business. But after a while, the emphasis on quality began to fade, and quality took a backseat to other concerns. However, there has been an upsurge recently in the need for attention to quality. Much of this has been driven by recent experience with cost and adverse publicity associated with wide-ranging recalls that have included automobiles, ground meat, toys, produce, dog food, and pharmaceuticals. So, ang mga customers may mga iba-iba nga mga requirements. So, because of that, ang quality ga-depend gayud sa customers' requirements. Defining quality, the dimensions of quality. One way to think about quality is the degree to which performance of a product or service meets or exceeds customer expectations. The difference between these two, that performance minus expectations, is of great interest. If these two measures are equal, the difference is zero, and expectations have been met. If the difference is negative, expectations have not been met. Whereas, if the difference is positive, performance has exceeded customers' expectations. Product quality is often judged on 8 dimensions of quality. Number 1 is performance. Amo dan ang mga main characteristics of the product. Number 2, aesthetics, ng appearance, feel, smell, taste ng product. Ngayon, ng special features are the extra characteristics. The conformance, how well a product corresponds to design specifications. Reliability, dependable performance. Next, durability, the ability to perform over time. Next, perceived quality, direct evaluation of quality, example, reputation. And lastly, service ability, handling of complaints or repairs. Examples of the 8 dimension. First one is performance. Everything works, fit, finish, ride, handling, and acceleration. Sa aesthetics, exterior and interior designs, features, convenience, placements of gauges, high-tech GPS system, safety, anti-skid airbags. Number 4, conformance. Car matches manufacturer's specifications. Number 5, reliability, infrequent need for repairs. Number 6, sa durability, useful life in miles, resistance to rust. And 7, perceived quality, kung top rated. Lastly is service ability, ease of repair. Service quality. The dimensions of product quality don't adequately describe service quality. Instead, service quality is often described using the following dimensions. First one is convenience. More than ang availability and accessibility of the service. Next is reliability, the ability to perform a service dependably, consistently, and accurately. Next, responsiveness, the willingness of service providers to help customers in unusual situations and to deal with problems. 4. Time, the speed with which service is delivered. Number 5 is assurance, the knowledge exhibited by personnel who come into contact with a customer and their ability to convey trust and confidence. 6 is courtesy, the way customers are treated by employees who came into contact with them. And 7, tangibles, the physical appearance of facilities, equipment, personnel, and communication materials. And lastly is consistency, the ability to provide the same level of good quality repeatedly. Diyan pagid ang mga examples kang 8 dimensions kang service quality. First is the convenience, di ba? Kung was the service center conveniently located. Next is the reliability. Was the problem fixed and will the fix last? Sa responsiveness, were customer service personnel willing and able to answer questions? Sa time, how long did the customer have to wait? Number 5, assurance. Did the customer service personnel seem knowledgeable about the repair? So number 6, courtesy. Were customer service personnel and their cashier friendly and courteous? Number 7 is tangibles. Were the field facilities clean? And were personnel neat? And lastly, sa consistency, was the service quality good? And was it consistent with previous visits? The determinants of quality. The degree to which a product or a service successfully satisfy its intended purpose has 4 primary determinants. Mudya ang mga primary determinants kung para maman-an kung nasatisfy gid man kang product or service ang customers. So, number 1 is nang design kang product. Number 2, how well the product or service conforms to the design. And number 3 is of use. Number 4 is service after delivery. The quality of design. It refers to the intention of designer to include or exclude certain features in a product or a service. So, ang quality of design ang amuran kung i-include bala or i-include bala or exclude ang features kang product or service. For example, many different models of automobiles are on the market today. They differ in size, appearance, roominess, fuel economy, comfort, and materials used. These differences reflect choices made by designers that determine the quality of design. Design decisions must take into account customer wants, production or service capabilities, safety and reliability, both during production and after delivery, cost, and other similar considerations. Next is quality of conformance. It refers to the degree to which goods and services conform to the intent of the designer. Ang quality of conformance man tana amuran ang how well the product meet ang specific standards ka mga designers. This is affected by factors such as the capability of equipment used, the skills, training, and motivation of workers, the extent to which the design lends itself to production, the monitoring process to assess conformance, and the taking of corrective action through problem solving when necessary. One important key to quality is reducing the variability in process outputs, reducing the degree to which individual items or individual service acts vary from one another.
Responsibility for quality. It is true that all members of an organization have some responsibility for quality, but certain parts of the organization are the key areas of responsibility. So, The quality of the product is dependent on the quality of the process, input materials, staff, data, process, systems, etc. So everybody is responsible for the part of the cake. Such as the first is the top management. It has the ultimate responsibility for quality. The top management establishing strategies for quality and must institute programs to improve quality. So the top management are the one who is responsible in directing, guiding, and motivating managers and workers, and being a role model by involving themselves in quality initiatives. Second is design. Design quality products and services begin with design. So, these include not only features of the product and services. It also includes attention to the processes that will be required to produce the product or the services that will be required to deliver the service to customer. So design in order for your customer to buy your product or service, you need to first get their attention, and this is by having a good quality of design. Third is procurement. This department has responsibility for obtaining goods and services that will not detract from the quality of the organization's goods and services. Fourth is production or operation. It has responsibility to ensure that processes yield products and services that conform to design specification. Monitoring processes and finding and correcting root causes of problems are important aspects of this responsibility. So, the product or operation are the ones who is finding the root or the causes of the problems that may occur. Fifth is the quality assurance. It is responsible for gathering and analyzing data on problems and working with operation to solve problems. So, if the production or operation are the ones who is finding the roots of the problems, the quality assurance are the ones who gathers the problems and analyzing the data and work with operations finding solutions to solve the problems. Next is packaging and shipping. This department must ensure that goods are not damaged. So, the packaging and shipping are the one who make sure that the goods or the products that has been ordered is not damaged in transit. The packages are clearly labeled, the instructions are included, and that the goods will be shipped in timely manner. So they make sure that your customer will receive their goods or product in the time frame that you have been suggested. Next is marketing and sales. It is the department that has the responsibility to determine customer needs and to communicate with them. So, in addition, it has the responsibility to report any problems with product or services. Lastly, the customer service. It is often the first department to learn of problems. It has the responsibility to communicate that information to appropriate departments, deal in a reasonable manner with customers, work to resolve problems, and follow up to confirm that the situation has been effectively remedied. So, as you can see in malls or supermarkets or even in department stores, there are customer service where we customers can directly inquire our problems or ask for help with them. Next, the consequences of poor quality. So why do we need to make sure that our goods or products or even the services has a good quality? Of course, it is important for management to recognize the different ways in which the quality of a firm's products or services can affect the organization and to take this into account in developing and maintaining a quality assurance program. Some of the major affected areas of the quality are, so if you have a bad quality, it can cause you to loss of business, high cost of liability, low production, and high costs. So, the costs of quality are, it is divided into three categories, which are the appraisal cost, prevention cost, and failure cost. So let's discuss first the appraisal cost. Appraisal costs relate to inspection, testing, and other activities intended to uncover defective products or services, or to assure that there are none. They include the cost of inspectors, testing, test equipments, lab quality audits, and field testing. So, in the prevention cost, it is related to attempts to prevent defects from occurring, and they include costs such as planning and administration system, working with vendors, training, quality control procedures, and extra attention in both the design and production phases to decrease the probability of defective workmanship. And in failure cost, actually failure cost has two categories, which are the internal failures and external failures. But first, failure costs are incurred by defective parts or products or by faulty services. Internal failures are those discovered during the production process, while the external failures are those discovered after delivery to the customer. So in internal failures, it occurs for a variety of reasons, including defective materials from vendors, incorrect machine setting, faulty equipment, and incorrect methods, incorrect processing, carelessness, and faulty or improper material handling procedures. So, the costs of internal failures include lost and possible employee injury, rework costs involve the salaries, works, and the additional resources needed to perform the rework, such as equipment, energy, and raw materials. So, those external failures are when they find the product or the goods has damage while it is being shipped.
Good day everyone, I am Antoinette P. Bancal and I will going to report the evolution of quality management. So first is Industrial Revolution. So in this time, the Industrial Revolution time, the quality management take place as skilled craftsmen perform all the stages of production. So pride of workmanship and reputation often provided the motivation to see that a job was done right. So, and also, a division of labor accompanied the Industrial Revolution. Each worker was then responsible for only a small portion of each product. So, pride of workmanship became less meaningful because workers could no longer identify readily with the final product. So, division of labor. When we say division of labor, there's a certain type of work for a certain person. So ginahati-hati ron ang job for a certain person, dapat jaobrahon mo, tapos ang one person is jaobrahon mo. So it takes place in Industrial Revolution. So next, so the father of scientific management is Frederick Winslow Taylor. So si Frederick Winslow Taylor, he gave a new emphasis to quality by including the product inspection and gauging in his list of fundamental areas of manufacturing management. So, sa first, sa Industrial Revolution, so, ging panghati-hati pala ang division of work, division of labor, ang mga ginaobra is ginhati-hati pa lang. So, si Frederick Winslow is he gave new emphasis, which is including the product inspection. So, additional information about the father of scientific management, Frederick Winslow Taylor was an American mechanical engineer. He was widely known for his methods to improve industrial efficiency. He was one of the first management consultants. So, next is in the year 1924, what is the quality management is? So, In 1924, Bell Telephone Laboratories introduced statistical control charts that could be used to monitor production. And around 1930, Western electrical engineer Walter Shewhart proposed a method for statistical analysis and quality control. Or he introduced the tables for sampling. So in 1924, may nagsulod rin ang Division of Labor, inspection of a product. So in 1924 ag 1930, nagsulod ang control of charge that could be used to monitor the production. So sa 1940 man tana, statistical sampling techniques, a change and development were brought forth during the 1940s by industry leaders and experts like Deming, Dodge, Horan, and Roming. This would be the beginning of total quality management as we know today. So inspection were now carried out by production personnel. So next is the 1950. The quality movement involved into quality assurance. So during the 1950s, the movement involved into quality assurance. So in the mid-1950s, total quality controls efforts enlarged the realm of quality efforts from its primary focus on manufacturing and also include the product design and incoming raw materials. So one important features of this work was greater involvement of upper management in quality. So during 1960s, the concept of zero defects gained favor. This approach focused on the employee motivation and awareness and the expectation of perfection from each employee. It evolved from the success of the Martin Company in producing a perfect missile for U.S. Army. And then, the 1970 quality assurance method gained increasing emphasis in services including government operation, healthcare, banking, and travel industry. So, the evolution of quality took a dramatic shift from quality assurance to a strategic approach to quality in the late 1970s. Up until that time, the main emphasis had been finding and correcting defective products before they reach the market. So in 1970s kunod, gina-check gud nanda ang andang product before maka-reach sa market or sa certain consumers or customers. So the strategic approach is proactive, focusing on preventing mistake from occurring in the first place. The idea is to design quality into products rather than find of correct defects after the fact. So this approach has now expanded to include processes and services. So quality and profits are more closely linked. This approach also places greater emphasis on customer satisfaction and involves all level of management as well as the workers in continuing effort to increase quality. So in this time, nagsama-sama na sila the satisfaction of customers and also the quality of the products.
The foundations of modern quality management, the gurus, a core of quality pioneers, shape current thinking and practice. This section describes some of their key contributions to the field. First is Walter Shewhart was a genuine pioneer in the field of quality control, and he became known as the father of statistical quality control. He developed control charts for analyzing output of process to determine when corrective action was necessary. While Walter Shewhart proposed new attributes and variables in his control charts that to improve quality and reduce scrap and common cause variation that should be controlled. This would allow the distinction between assignable and chance cause variations. By keeping the process in control, it will be possible to predict future output and economically manage processes. Shewhart had a strong influence on the thinking of two other gurus, W. Edwards Deming and Joseph Juran. W. Edwards Deming is a statistics professor at New York University in the 1940s, went to Japan after World War II to assist the Japanese in improving quality and productivity. The Union of Japanese Scientists who had invited Deming were so impressed that in 1951, after a series of lectures presented by Deming, they established the Deming Prize, which is awarded annually to the firms that distinguishes themselves with quality management programs. Although the Japanese referred Deming, he was largely unknown to business leaders in the United States. In fact, he worked with the Japanese for almost 30 years before he gained recognition in his own country. Before his death in 1993, U.S. companies turned their attention to Deming, embraced his philosophy, and requested his assistance in setting up quality improvement programs. So, there are 14 points of management. These 14 points of management is a set of management practices to help companies increase their quality and productivity. First is to create constancy of purpose toward improvement of product and services. Second, reduce level of delays, mistakes, defective materials, and defective workmanship. Third, cease dependence on mass inspection, which is to prevent defects rather than detect defects. Fourth, eliminate suppliers that cannot qualify with statistical evidence of quality. Fifth, find problems. It is management's job to work continually on system improvement. Sixth, institute modern method of training on the job. 7. Emphasize quality instead of volume alone. Management must prepare to take immediate action on reports from foremen concerning barriers such as inherent defects, machines not maintained, poor tools, and fuzzy operational definitions. 8. Drive out fear, so that everyone may work effectively for the company. 9. Break down barriers between departments. People in research, design, sales, and production must work as a team. 11. Eliminate goals and slogans asking for new levels of productivity without providing methods. 10th rather. Eliminate goals and slogans asking for new levels. 10. Eliminate goals and slogans asking for new levels of productivity without providing methods. 11. Eliminate work standards that prescribe numerical quotas. 12. Remove barriers that stand between the hourly work and this right to pride for workmanship. 13. Institute a vigorous program of education and retraining. And last, 14. Create a structure in top management that will push every day on the above 13 points. Joseph M. Juran. Juran, like Deming, taught Japanese manufacturers how to improve the quality of their goods, and he, too, can be regarded as major force in Japan's success in quality. Juran viewed quality as fitness for use. He also believed that roughly 80% of quality defects are management controllable. Thus, management has the responsibility to correct this deficiency. He described quality management in terms of a trilogy consisting of quality planning, quality control, and quality improvement. According to him, quality planning is necessary to establish processes that are capable of meeting quality to standards. Quality control is necessary in order to know when corrective action is needed, and quality improvement will help to find better ways of doing things. Durant's philosophy key element is the commitment of management to continual improvement. Next, Armand Feigenbaum. Feigenbaum was instrumental in advancing the cost of nonconformist approach as a reason for management to commit to quality. He recognized that quality was not simply a collection of tools and techniques but a total field. According to him, it is the customer who defines quality. Next, Philip B. Crosby. Philip B. Crosby developed the concept of zero defects and popularized the phrase "do it right the first time." He stressed prevention, and he argued against the idea that there will always be some level of defectives. So zero defects where there are zero defects means there are no costs associated with issues or poor quality. In 1979, his book Quality is Free was published. Quality is free concept is that the costs of poor quality are much greater than traditionally defined. According to Crosby, these costs are so great that rather than viewing quality efforts as costs, organizations should view them as a way to reduce costs because the improvement generated by quality efforts will more than pay. Believes that any level of defects is too high, and he maintains that achieving quality can be relatively easy. His book Quality Without Tears: The Art of Hassle-Free Management was published in 1984. Next is Kaoru Ishikawa. The late Japanese expert on quality was strongly influenced by both Deming and Durant. Although he made significant contributions of his own to quality management, among his key contributions were the development of the cause and effect diagram, or also known as the fishbone diagram, for problem solving, and the implementation of quality circles which involved workers in quality improvement. The cause and effect diagrams, or fishbone, is a method for analyzing process dispersion. The diagram relates cause and effects, wherein it helps to visualize the potential causes in order to find the root cause of a particular problem, and helps to identify, analyze, and improve quality issues. Next, the quality circles, a participatory management technique that enlists the help of employees in solving problems related to their own jobs. Next, Genichi Taguchi, best known for the Taguchi loss function, which involves a formula for determining the cause of poor quality. It is a graphical depiction of loss, wherein the loss imparted to the society by the product from the time the product is designed to the time it is shipped to the customer. Taiichi Ono and Shigeo Shingo. Taiichi Ono and Shigeo Shingo both developed the philosophy and methods of Kaizen. Bu nami man tanga Taiichi Ono and Shigeo Shingo. Taiichi Ono and Shigeo Shingo both developed the philosophy and methods of Kaizen. a Japanese term for continuous improvement. At Toyota, continuous improvement is one of the hallmarks of successful quality management. Continuous improvement, or Kaizen, is a method for identifying opportunities for streamlining work and reducing waste in the form of cost, time, and defects. Um, it is used by thousands of companies all over the world to identify saving opportunities. But there is a cycle which is identify, plan, execute, and review. This cycle means to seek opportunities in the process workflows, plan to improve the process, then implement changes, and lastly, review or check the result of the change. This is the summary of their key contributions. Okay, Schuhart, control charts and variance reduction. Deming, 14 points of management, special versus common causes of variation. Juran, quality is fitness for use and quality trilogy. The quality trilogy, which are the quality planning, quality control, and quality improvement. Feigenbaum, quality is a total field. The customer defines quality. Crosby, quality is free and zero defects. Ishikawa, cause and effect diagrams and quality circles. Taguchi, the Taguchi loss function. And last, Ono and Shingu, the continuous improvement or Kaizen.
Quality awards. Quality awards have been established to generate improvement in quality. The Malcolm Baldrige Award, the European Quality Award, and the Deming Prize are well-known awards given annually to recognize firms that have integrated quality management in their operation. The Baldrige Award, named after the late Malcolm Baldrige, an industrialist and former Secretary of Commerce. The annual Baldrige Award is administered by National Institute of Standards and Technology. The purpose of the award competition is to stimulate efforts to improve quality, to recognize quality achievements, and to publicize successful programs. The organizational profile chart includes management, relationships, and challenges. Number 1, leadership. Number 2, strategic planning. Number 3, customer and market focus. Number 4, measurement, analysis, and knowledge management. Number 5, workforce focus. Number 6, process management. And number 7, business results. The European Quality Award. The European Quality Award is Europe's most prestigious award for organizational excellence. The European Quality Award sits at the top of regional and national quality awards, and applicants have often won one or more of those awards prior to applying for the European Quality Award. The Deming Prize. The Deming Prize, named in the honor of the late William Edwards Deming, is Japan's highly coveted award recognizing successfully quality efforts. It is given annually to any company that meets the award standards. Although typically given to Japanese firms, in 1989, Florida Power and Light became the first U.S. company to win the award.
Quality certification. Many firms that do business internationally recognize the importance of quality certification. ISO 9000, 14000, and 247,000. The International Organization of Standardization, or ISO, promotes worldwide standards for the improvement of quality, productivity, and operating efficiency through a series of standards and guidelines. Used by industrial and business organizations, regulatory agencies, governments, and trade organizations, the standards of important economic and social benefits. Two of the most well-known of these are ISO 9000 and ISO 14000. ISO 9000 pertains to quality management. It concerns what an organization does to ensure that its product or services conform to its customers' requirements. ISO 4000 concerns what an organization does to minimize harmful effects to the environment caused by its operations. So ISO 4000 is an organization who minimizes harmful effects to the environment caused by its operations. Kung marangga man ang anda nga minimize harmful effects, minimize nanda ang effects ng environments because sa anda nga operations. Problem solving. So problem solving is one of the basic procedures of TQM. In order to be successful, problem solving efforts should follow a standard approach. TQM problem process. So the plan, do, study, act cycle. The plan, do, study, act or PDSA cycle, also referred to as either Shewhart cycle or the Deming wheel, is the conceptual basis for problem-solving activities. The cycle is illustrated in Figure 9.2, representing the process with the circle underscores its continuing nature. So sa Figure 9.2, A, amo ang PDSA cycle, which is the plan, act, plan, do, act, plan, do, study, and act. So sa Figure 9.2A, so plan. First is plan. There are four basic steps in the cycle. First is plan. So plan. Begin by studying the current process. Document that process. Then collect data on the process or problem. Next, analyze the data and develop a plan for improvement, and specify measures for evaluating the plan. So first in the cycle is the plan. Next is do. Implement the plan on a small scale if possible. Document any changes made during this phase. Collect data systematically for evaluation. Third is study. Evaluate the data collection during the do phase. Check how closely the results match the original goals of the plan phase. So, i-check kuno natin ang ginuubra natin sa do nga step. Tapos, kung okay ng result, kag na-match ta na sa plan nga phase, amo rin kita madiritso sa act nga phase. If the results are successful, standardize the new method and communicate the new method to all people associated with the process. Implement training for the new method. So kung natapos nito ang tatlo nga steps nga to, amor na nga pwede sandarin ka standard kang new method kag iko pwede communicate sa bag-uri man nga method kag i-associate na with the process. Kag i-implement rin ang bag-o nga method. Next is process improvement. Process improvement is a systematic approach to improving a process. It involves documentation, measurement, and analysis for the purpose of improving the functioning of a process. Typical goals of process improvement include increasing customer satisfaction, achieving higher quality, reducing waste, reducing cost, increasing productivity, and reducing processing time. So, sa Figure 9.3, the process improvement cycle is another version of the plan, do, study, act cycle. So, another one na kang version na. So, first is select a process. Second is study or document. Seek ways to improve it. Design an improved process. Next is implement the improved process. Evaluate and document. Quality tools. There are a number of tools that an organization can use for problem solving and process improvement. This section describes 8 of these tools. The tools aid in data collection and interpretation and provide the basis for decision making. The first 7 tools are often referred to as the 7 basic quality tools. First one is flowcharts. A flowchart is a visual representation of a process. As a problem-solving tool, a flowchart can help investigators in identifying possible points in a process where problems occur. Figure 9.5 illustrates a flowchart for a catalog telephone orders in which potential failure points are highlighted. The diamond shapes in the flowchart represent decision points in the process, and the rectangular shapes represent procedures. The arrows show the direction of flow of the process, of the steps in the process. To construct a simple flowchart, begin by listing the steps in a process. Then classify each step as either a procedure or a decision or checkpoint. Try to not make the flowchart too detailed or it may be overwhelming. But be careful not to omit any key steps. Second is check sheets. A check sheet is a simple tool frequently used for a problem identification. Check sheets provide a format that enables users to record and organize data in a way that facilitates collection and analysis. This format might be one of simple check marks. Check sheets are designed on the basis of what the users are attempting to learn by collecting data. Many different formats can be used for a check sheet, and there are many different types of sheets. One frequently used form of check sheet deals with type of defect, another with location of defect. These are illustrated in figure 9.6 and 9.7. Figure 9.6 shows tallies that denote the type of defect and the time of day each occurred. Problems with missing labels tend to occur early in the day, and smeared print tends to occur late in the day, whereas off-center labels are found throughout the day. Identifying types of defects and when they occur can help in pinpointing causes of the defects. Figure 9.7 makes it easy to see where defects on the product. In this case, a glove are occurring. Defects seem to be occurring on the tips of the thumb and first finger in the finger valleys, especially between the thumb and first finger, and in the center of the gloves. Again, this may help determine why the defects occur and lead to a solution. Third, histograms. A histogram can be useful in getting a sense of the distribution of observed values. Among other things, one can see if the distribution is symmetrical, what the range of values is, and if there are any unusual values. Figure 9.8 illustrates a histogram. Note the two peaks. This suggests the possibility of two distributions with different centers. Possible causes might be two workers or two suppliers with different quality. Frequency histogram, a chart that shows an empirical frequency distribution. Fourth, the Pareto analysis. Pareto analysis is a technique for focusing attention on the most important problem areas. The Pareto concept, named after the 19th century Italian economist Vilfredo Pareto, is that a relatively few factors generally account for a large percentage of the total cases. Example for this is the complaints, defects, and problems. The idea is to classify the cases according to degree of importance and focus on resolving the most important, leaving the less important. Often referred to as the 80 to 20 rule. The Pareto concept states that approximately 80% of the problems come from 20% of the items. For instance, 80% of machine breakdowns come from 20% of the machines, and 80% of the product defects come from 20% of the causes of defects. Often it is useful to prepare a chart that shows the number of occurrences by category arranged in order of frequency. Figure 9.9 illustrates such a chart corresponding to the check sheet shown in figure 9.6. The dominance of the problem with off-center labels becomes apparent. Presumably, the manager and employees would focus on trying to resolve this problem. Once they accomplish that, they could address the remaining defects in similar fashion. Smeared print would be the next major category to be resolved, and so on. Additional check sheets would be used to collect data to verify that the defects in these categories have been eliminated or greatly reduced. Hence, in later Pareto diagrams, categories such as off-center may still appear but would be much less prominent. Pareto chart, a diagram that arranges categories from highest to lowest frequency of occurrence.
The fifth basic quality tool is the scatter diagram. A scatter diagram can be useful in deciding if there is a correlation between the values of two variables. A correlation may point to a cost of a problem. In figure 9.10 shows an example of scatter diagram. In this particular diagram, there is a positive or upward sloping relationship between the humidity and the number of errors per hour.
High values of humidity correspond to high numbers of errors, and vice versa. On the other hand, a negative or downward sloping relationship would mean that when values of one variable are low, values of the other variable are high, and vice versa. In figure 9.10, it shows a graph. The graph shows the degree and directions of relationship between two variables. You can see they are using the dots to identify the differences between the relationship of the two variables. Next is a control chart. A control chart can be used to monitor a process to see if the process output is random. It can help detect the presence of correctable cause of variables. In figure 9.11 illustrates a control chart. Control charts also can indicate when problem occur and give insight into what caused the problem. Control charts are described in detail in chapter 10. There is statistical chart of time, ordered values of sample statistic. Example is sample means. The example of control chart uses the upper control limit and lower control limit and the time. Next is the cause and effect diagrams. A cause and effect diagrams occurs a structured approach to the search of the possible causes of the problem. It is also known as the fishbone diagram because of its shape, or an Ishikawa diagram after the Japanese professor who developed the approach to aid workers overwhelmed by the number of possible sources of problems when problem solving. This tool helps to organize problem-solving efforts by identifying categories of factors that might be causing problems. Often, this tool is used after brainstorming sessions to organize the ideas generated. In figure 9.12 illustrates one form of cause and effect diagram. The cause and effect diagram has its format using materials, people, equipment, method, and the problem. A diagram used to organize a search for the cause of a problem, also known as a fishbone diagram. The cause. Example in figure 9.13, cause and effect diagram of airline ticket errors. Method printing. Under the method printing is the quality and the speed. Under the personal is the ability, which is attention to detail and the supervision. The materials used or the ticket stacks are uses age and density, carbon, paper. In the machine, we can identify the type, the age, the maintenance, frequency, and under the maintenance, the tension adjustment and the printing quality. And the effect will be the airline ticket errors. Let's move on the benchmarking. Benchmarking is an approach that can inject new energy into improving efforts. Summarized in table 9.9, benchmarking is the process of measuring an organization's performance on the key customers' requirements against the best in the industry or against the best in any industry. Its purpose is to establish a standard against which performance is judged and to identify a model for learning how to improve. A benchmark demonstrates the degree to which customers or other organizations are satisfied. Once a benchmarking has been identified, The goal is to meet or exceed the standard through improving its appropriate process. The benchmarking process also involves these steps. First is identify a critical process that needs improvement. Example, order entry, distribution, service after sale. Second is identify any organizations that excels in the process, preferably the best. Next is contact the benchmark organization, visit it, and study the benchmark activity. Fourth is analyze the data. And lastly, improve the critical process at your own organization. That's all. I hope you have learned something in our report. This report is made by Group 4 and the members are Bangkal Antoinette, Bernardino Renalyn, Castellano Francesca, Domingo Iris Jade, Estumata Micaela Shaira, Montiliano Roxanne, Samiliano Maki, and Serino Kate. Thank you!